Hello, welcome to this session on trig identities. We're looking at the Pythagorean identities and looking at the further identities we now need for year 2 of A-level maths. From year 1, we've got sine squared plus cos squared is 1. Then introducing in year 2, we have tan squared plus 1 is sec squared and 1 plus cot squared is cosec squared. If we know this, we can derive these. We just divide everything in the top one by cos squared. And then we get sine squared over cos squared is tan squared. Cos squared over cos squared is 1. And 1 over cos squared is sec squared. Same kind of principle for this bottom one here. I divide everything in the top one by sine squared. Sine squared over sine squared is 1. Cos squared over sine squared is cot squared. And 1 over sine squared is cosec squared. Just remember, cos over sine is cot because it's 1 over tan. Well, let's look at how we apply this. Okay, let's have a look at this exam question. We're going to go from, this is part A, sine squared theta plus cos squared theta, which is equivalent to 1. I'm going to try and show why that is 1 plus tan squared is equivalent to sec squared. Well, we're going to divide through by cos, or cos squared, sorry. So I'm going to divide everything by cos squared theta on both sides. Sine squared over cos squared is, of course, tan squared. Cos squared over cos squared is 1. And then 1 over cos squared is sec squared theta. And then we could just write that as it is. Is equivalent to sec squared. So the point of that question there, that part, is to show that you can derive the given Pythagorean identity, dividing through by cos squared. Okay, that's part A done. Let's look at part B. Now, we're dealing with 2 tan squared theta plus sec theta equals 1. We need to solve it. Now, the rule is you look at what's squared and you replace that because we have an identity to replace that. And I can change that to something to do with sec. So tan squared will equal sec squared theta minus 1, just by rearranging 1 plus tan squared is sec squared. So that's your first step to solve that. 2 sec squared theta minus 2 plus sec theta equals 1. 2 sec squared theta plus sec theta minus 3 equals 0. I would like to write it with a dummy variable, so I'm going to say 2y squared plus y minus 3 equals 0. And then we solve that equation. Okay, so I can factorise this. It's going to give me 2y plus 3 y minus 1 equals 0. So I'm going to have solutions y, which is of course sec theta equals negative 3/2 and 1. So with our reciprocal function in mind, that's saying, okay, so cos theta must equal negative 2/3. Just take the reciprocal. The reciprocal of 1 is still 1. Well, what does theta equal then? Well, we're solving this between 0 and 360. Well, when is cos 1? That's when theta equals 0. 360 is not in the range of possible values. And just using our calculator, we can get 131.8 degrees, and also theta equals 228.2 degrees using my multiple solutions. So cos theta equals 1. That gives me 0. Cos theta equals negative 2/3 gives me 131.8 and 228.2. So let's just recap what we've done. We've got the quadratic equation. I need to replace tan squared with sec squared minus 1, rearrange, solve, factorise. I get a solution for sec, take the reciprocals to put that into cos, and then using calculations I get my answer. I hope that is clear. Let's have a little look at where the marks are. Well, there's A, finding the identity. Here's B, substituting and solving. Your solutions for sec, put them into cos, and there you go. Well, that's a really nice example to look at introducing using these Year 2 trig identities. Thank you very much.